Hi guys, namaste. Welcome back to AppSec Zero. In our previous videos, we saw how we can exploit broken access control vulnerabilities. If you haven't watched them yet, I'll provide the playlist link in the description. In this video, we are going to actually see how we should be securing our web applications by scanning code using tools to find vulnerabilities. This testing is called SAST, Static Application Security Testing. So here we are going to use two open source code scanning tools, SonarCloud and Snyk. Here we have three different projects in these tools. All the three projects have different vulnerabilities present, and we are going to find out which of these projects has OWASP top 10's first vulnerability, broken access control. So these are first tool SonarCloud and these are second tool Snyk. Now let's explore these tools to see how they identify vulnerabilities in code and see what precautions or steps we need to follow to mitigate these vulnerabilities. Well, our motto is zero bugs, zero risk. So we want to mitigate bugs at code level so that there will not be any security threats to take care of at production or testing level. Let's go to DVC Sharp API project. Here in Issues tab, here the tool have identified multiple vulnerabilities. So these might be true positive or false positive. Now what we have to do is that we need to go through these vulnerabilities and see if the vulnerabilities that the tool have identified is either true or false. So as of now, let's go to security category and select authentication. So broken access control occurs when authentication or authorization fails. So this is the only reason that we are going into authentication to check for broken access control vulnerabilities. So here we have two instances of JWT secret keys should not be disclosed. Before seeing this vulnerability, let's see what a JWT token is. So this is what a JWT token looks like. So we need to send a JWT token from client side or website to server side, which is hosting API endpoints. When a JWT token is sent to the server, first it checks for the header. This red part is header of the JWT token. So the header contains algorithm information and servers has JWT secret with it. Now the server encrypts this payload data with token secret and it generates a signature. Now it verifies that signature with the signature that is present in JWT token. If the generated signature matches with the signature that is sent, the token is valid. So a JWT secret is only known to the server. Any change in the payload will lead to invalid signature, and attacker cannot produce valid signature as he doesn't have token secret with him. So this is how JWT works. Now as we know how JWT token works, let's get back to the tool and see the issue. Here it says JWT secret keys should not be disclosed. So the JWT secret key is disclosed. Let's go to the file and see about it. So here is the BFL best fix location. Okay, as we can see, here is a token secret. As we have discussed before about JWT, when the token secret is disclosed, we can change the signature of JWT token, leading to authorization issues. In general, as this is a server code, there might not be much probability for a user to get this code. But if we find such JWT token secrets in GitHub or Bitbucket or whatever repos that is published in, and if it's publicly accessible, then this is an issue. Now coming to second one in startup.cs. Here it is showing the same issue as well, but generally here the issuer signing key is being taken from models.user.token secret. So this model.user.token secret is in models folder. So it's saying here the token secret is present in this file and it is being consumed in startup.cs. So both are same instances. Now let's go to our second tool Snyk and see for such vulnerabilities in our project. So these are DVC Sharp API project. Let's go to code analysis. Unlike our previous tool, the interface differs and we don't have vulnerability based on OWASP categories, but here there are vulnerability types. So here we have around 7 vulnerabilities, and this is password hash computation, XML injection, hard-coded secret, use of hard-coded credentials, server-side request forgery. So let's select hard-coded secret and use of hard-coded credentials because these what makes sense regarding broken access control. And if we see details here, it's again saying the same thing, that there's token present here and it's using a signing key. And coming to the next instance, it's again the same. So this tool has identified the same thing for broken access control as well. Now let's check out the other two projects to see such vulnerabilities. So here we have Juice Shop project. Let's see for OS vulnerabilities that are present in, broken access control vulnerabilities that are present in this project. Okay, so here we have only one vulnerability regarding authentication. Here it says make sure the private key gets revoked, changed, and removed from the code. So here it's saying that the private key is present in this code. So here is the private key that is present. Now let's do one thing. Let's copy this and see where this code is using this private key. As we can see, there are two places, one for creating a HMAC and other is for signing the JWT token. So what happens is that JWT token is signed using private key and public key is used to verify the signature. If the private key is exposed in such way, we can create our own payloads. As I said before, only if the code is publicly available, there's chance of getting this private key. Uh, So now let's explore our other tool Snyk to see if it found any new vulnerabilities in Joomla project regarding broken access control vulnerability. Let's go to code analysis. Here there are multiple vulnerability types. Let's select those vulnerabilities that are related to broken access control. So here we see there's insecure JWT verification. So let's select this. Let's select use of hard-coded credentials. We might find some credentials, hard-coded secret as well, and there are no other vulnerabilities that are related to broken access control. So let's see one by one. So here, this is a false positive because it identified this specific string as hard-coded secret, which is not. So there might be such possibilities where tool might identify false positives as well. Mm, Okay, so as we can see, there's private key here, which we have discussed in our previous tool. It's the same thing. Okay, it's the same instance again. Oh, here there's other one, use of hard-coded credentials. As we can see here, we found the password for a post request, which could lead to broken access control. We should never hard-code credentials. We see more such hard-coded credentials here. This is the email. This is the password. This is another email, I guess. And this is the password. Okay, let's explore more. As we can see, there are such multiple hard-coded credentials that are present in these files. Let's just remove hard-coded secret and hard-coded credentials as we have explored these two. Coming to hard-coded credentials, there are 133 places where we can find hard-coded credentials, so we need to take care of it. And coming to insecure JWT verification, let's look into it. See, here there's description. It says a JWT decode method is used that decodes the token but does not check its validity or integrity. So here is a mistake that developers might do. So the thing is that they'll implement JWT, but they'll never verify JWT signature to see if the JWT is valid or not. They'll directly decode the JWT that they get before validating the signature. So what happens is that when you don't validate the signature and directly decode it and use it, when the reliability token payload is changed, the signature will not be valid. But as you are not checking for the signature, you are not validating the signature of reliability token, you are just consuming the reliability token that the client is giving or the hacker or the attacker is giving. This should not be done. So this is it for this project regarding broken access control vulnerabilities. Now let's try our third project, which is web code. Let's see what all vulnerabilities it has, and let's see vulnerabilities regarding broken access control. So here we have 9 instances for authentication. Okay, let's see. Revoke and change this password as it is compromised. So these are all regarding password change. So let's go through each of these. Okay, so this is just a login form that is written for HTML page, and these are just placeholders. So this false positive. And coming to the next one, as we can see here, there's JWT password, JWT secret that is hard coded, which is insecure. So this need to be removed. Oh, so they are using that JWT password here. This is what it's showing us the tool. This is the same instance again. This so as we can see, there's one more JWT password, which is base 64 encryption of victory. So this is not how we do it. We should never mention hardcore credentials. And what about this? Yeah, this is the same one JWT password, and they are using it here. This is the same one again, and we have two more to go. Yeah, the same instance. The last one. This is the form one, which is false positive. So let's go to our Snyk other tool to check for vulnerabilities in our last project web code. Yeah, let's go to code analysis. Okay, we have many instances of use of hard-coded credentials, hard-coded secret, hard-coded credentials, JWT signature verification, sensitive cookie. Okay, okay, yeah, coming to these instances, hard-coded secret. Let's see what this is about. Hard-coded value string is used as a cipher key. Okay, here JWT password is used, and where is it getting JWT password from? Here. So this was the issue that we saw earlier. This is the flow, this tool that's showing us the flow of vulnerability. What about this? It's same one. Okay, let's go back. This is the same instance as well, JWT password is the same one, and this is the same one as first one as we saw. This is the same one again. Okay, coming to JWT verification bypass. Let's see this one. The parse method does not validate the JWT signature. As we have already discussed, we need to verify the JWT signature first before decoding and using the JWT token. So, yeah, these are all the same one again. JWT bypass, use of hard-coded credentials. See here we have found different credentials for different users. We should never hard-code credentials. So, yeah, there are multiple instances of hard-coded credentials. Here we have credentials of some admin account, password admin account, or maybe this might be the salt for encrypting, and this has some other password. Okay, see this one. Here it's comparing with equal sign to see if it matches with username and password. This should not be done. These are the same instances. See, we found multiple hard-coded passwords in these projects. So actually, these projects are vulnerable projects. They actually created these projects to be vulnerable so that we can investigate and scan these projects and see how we can find vulnerabilities in them. I'll pro I'll provide these project links in the description, just like I did add these projects into these tools and try to analyze these projects on your own. So these are all the broken access control vulnerabilities that are present in this project. And coming to mitigation, whenever we use passwords or hard-coded credentials or whatever, we need to use environmental variables to store so that we get our passwords or token secrets or whatever from our environmental variables and use it in the code rather than storing it in the code itself, so that these passwords or hard-coded credentials are stored in OS level or server level than in the code level. Yeah. Thank you for watching. Keep learning, keep coding securely, and don't forget to like, share, and subscribe.